Alrighty, now CNT120, Chapter 1, we're going to look at some of the hardware we're going to find in the network. Again, I'm going to give you a little bit more than the book's giving you to help try to clarify some of the stuff they're talking about. Well, if I look at the picture of our basic LAN in the network, we run into things like switches, the NICs that we have on our desktops and servers to connect to those, and things possibly like routers in our network to make up some of the basic hardware we have on our network. So let's take a look at some of those. One of the first things they mention is a switch. We used to have hubs. Hubs were layer 1 devices. If I look back here, I would start off when I went from the bus topology to the star topology. This was a hub. The layer 1 hub device was a dumb device. It simply repeated everything that it got to all nodes. So that created a very busy network when it didn't need to be. Along came switches being layer 2, and layer 2 switches now read MAC addresses. They read layer 2 addresses. So the idea is, as a chunk of data comes into this switch, the switch reads the MAC address and says, oh, you want to go to this computer, not this one, so I'm going to send you to this computer. So it makes the network a lot less crowded with traffic because the switch is actually trying to send the data to only the intended node. So as I look down through, the switch is going to receive the incoming data, look at it, and try to make a decision by looking at the MAC address on where it needs to go. So it's going to read the MAC address. The switch itself maintains a table of MAC addresses. So this MAC address is on port 1, this MAC address is on port 2, this MAC address is on port 3. And when a chunk of data, when a frame of data comes into the switch, it's going to pick it up, look at it, and go, oh, you're going to this MAC address. Oh, that's port 12, and only pass it out port 12. So the end result is I can actually have computer 1 sending data to computer 2 at the same time computer 3 is sending data to computer 4. So we have many more conversations going on simultaneously, and I have a lot less traffic clogging up the network like I used to have in the old bus topology or the hub network. So a lot more efficient network. Our switches are very common today, and actually your little homeowner router that you have, those ports in the back are actually switch ports. So your homeowner router that you have at home, I'm looking at mine now while I'm talking, the ports in the back are actually switch ports. So that very common. Here are some examples going way down from 12 port, 24 port, 48 port to multi, 96, 100 port chassis switches like you would have in maybe one of the closets at your branch campus that you're at. Maybe if you're at the Lancaster campus, there might be one of these sitting in a closet next to the computer lab that you're in. That's your switch. Very common piece of the network. And actually, I remember a day where switches were expensive, and then I also remember a day where hubs were more expensive than the switches because there were less hubs being made. The next component you run into is a NIC, your network interface card. This is the circuitry in my computer that it's allowing my computer to connect to and communicate with the network. Every device that's connecting to a network has to have some kind of NIC in. So this is my connectivity device that's going to transmit and receive data on that network. It actually has a physical component, a physical layer component, a data layer component. The physical layer component is the physically plugging into the network, either into a fiber cable into a network or a copper cable into the network, or radio frequency radio waves to connect wirelessly to a network. So there's a physical component, and the data layer function is actually getting data onto the network. The data link layer is the part where I have to have some sort of mechanism to send and receive data on a wired network. That is going to be a CSMA-CD. We'll talk about that in a later chapter. Carrier sense multiple access with collision detect for wired networks, or on a wireless network, a CSMA-CA, carrier sense multiple access with collision avoidance for a wireless network. I need some mechanism, some method to get my data framed and on the network if it's wired, or framed and on the network if it's wireless. My NIC is doing that for me. So all my devices that are attaching to the network have to have some kind of NIC in, network card, to connect to the network. Well, here's various wired NICs, PCI NIC, PCI PCI Express NIC. Here is these are all copper NICs. Here's an old coax NIC in an ISA slot. Here's a fiber NIC, here's a USB to copper, here's an old laptop NIC. So they come in all kinds of various forms. Here's a USB wireless NIC, here's a PCI wireless NIC, here's a PCIe, PCI Express wireless NIC. They come in all various forms. Here's one for a printer. Here's one that would be built into an IP phone. I picked this because these are the IP phones that are in most places at the college at Hack. Very common IP phone. Here on the back are actually the network ports or the NIC built into the IP phone. Here is NICs built into the motherboard on my computer. You know, we used to buy a card and snap it into an expansion slot. Now it's built into the motherboard. Okay. Very, very common. Well, if I don't have a NIC built into the motherboard of my computer, which most do today, but if I don't, there was a day I had to buy a NIC and snap it into an expansion slot in my computer. Well, on my motherboard, I have PCI slots. If I go really old, I have ISA slots. Those are really old. PCI slots. I have PCI Express slots. These guys right here. Or I might actually connect into a USB port on my computer. If I have an old laptop, I might have a PCMCIA slot that I slid a NIC into. Here's an old ISA NIC, connecting to a coax bus. Here's an old PCI NIC for copper wired network. Here's a PCI for a wireless network. PCI Express for a wireless network. PCI for a wired network, or PCIe for a wired network. USB for wired and wireless. PCMCIA for wireless and wired, old laptop NICs, if you will. Okay, so my NICs come in various forms for connecting to different devices and also connecting to either wired or wireless networks. Those are very crucial, and again, these are built into almost everything: printers, desktops, laptops, printers. I even joke about your Coke machine and candy machine out in the lobby. Well, yeah, they have some kind of a NIC built into them. Might be a wireless NIC to a cellular network, if you will. But yes, things like that even have them built in too. So they're everywhere. Network cards. So switches, network cards, and routers. The chapter super quickly mentioned these, but my router is now the device that my switches will typically connect into, and the router serves a function of a couple things. One, it might just be there to connect multiple switches. Well, this might be a switch on floor 1, floor 2, floor 3. Or I'll think maybe if you're at the Harrisburg campus, you might have the Blocker building, the Whitaker building, and the bookstore, if you will. These might be 3 separate networks that the router's connecting together. 3 different buildings, 3 different floors that the router's connecting together. Or it could be even larger than that, depending on the facility. The router is also there to connect 2 separate sites. I might have the Harrisburg campus across a WAN link to the Lancaster campus, and the routers are serving the function of making that WAN connection. And that could be either an ISP connection or a leased line that the router is doing. So the router is there to make those bigger connections, either between buildings or between campuses or between, this city and that city, if you will. So the router is serving that function of doing the traffic managing, connecting either, my LAN out to the ISP or the LAN and the company out to the ISP, or even bigger yet. So it's managing the traffic between 2 or more networks, can help find the best path. Yes, the router's there to actually try to figure out the best path and try to route traffic that way all the time. Kind of like you do in your brain. You get in your car and go, okay, it's this time of day, I'm going to drive this way. The router's doing that kind of thing. The routers can be used in my small home office or up to industrial grade like I have in a company. And here I remind you, at home, your little router at home is connecting all these devices out to the ISP, and it's really these in a box. The router, the switch, access point, and router all in one box. So my devices are connecting to the switch into the router's connecting them out to my ISP, doing just like I do in a company. The router is designed to connect different networks, yes, usually a LAN to WAN kind of thing, or LAN to an ISP. And it usually is a multi-port kind of thing. It might connect 2 or 3 different switches out to an ISP or firewall, that kind of stuff. And it's designed to read all that, maintain all that, and make decisions on that. Oh, you're trying to go to the internet, I'll pass you this way. Oh, you're trying to go to the other building, I'll pass you this way. It's trying to make those decisions all the time. Typically, it's going to operate at layer 3, reading IP addresses. That's very typical, and make decisions based on those. It's going to be slightly slower than a switch because that has to interpret layer 3 data, but it's going to be able to do it more intelligently. You know, kind of like somebody asks you a very complicated question, you stop and think for a little bit, but then you give them a detailed answer. That's kind of what the router's doing. It takes just a fraction longer to process, but it's going to give you, you know, a better path decision to get you where it needs to be. If I crack open a router, I start seeing it's basically a specialized computer. That's really the only reason I threw this picture in, to get you to realize it is a specialized computer. It does not have the mouse and keyboard slots and the monitor port and all that kind of jazz, but it has all the other components that you're used to seeing inside of a computer, but it's just specialized for routing functionality. Here's ones that you would have for home. Here's ones that we would have in a large building. These are actually the ones we use in our lab room if you come on campus for classes. These are actually the 2011s that we're using in the lab. Alrighty. So there, super quickly, is kind of the overview of some of the hardware that you would find in a network. And like I said, even in your home, you're having NICs, switches, and routers in your home. We'll throw wireless access points in. I think it's chapter 6 we're going to do wireless access points, or wireless. But I have these components in most networks now. That's why they threw those hardware pieces in, and I kind of try to elaborate a little bit for you. Alrighty, when we come back, we'll dig into the OSI model.